Welcome to video 2 of the mean value theorem. Here we're looking at some visual representations of what the mean value theorem is really telling us. So if you read the directions, it says, for each of the functions, draw the segment indicated between the indicated points on the graph. And the question is there a point on the graph between those two indicated points where the slope of the line segment to the point is equal to the slope between the given points? If so, sketch the tangent line. And so this is what the mean value theorem is telling us, is that the slope of the line to the point, that would be the instantaneous rate of change, is equal to the slope between the given point, that would be the average rate of change. And so if I were to draw a line connecting my 2 points, obviously I can tell that my slope is positive. I don't know exactly what it is, but my slope is a positive, and I could figure it out. But my slope is a positive slope. What we're saying is there a point in between -2, x equals +2, and x equals +7, where if I draw the tangent line, it's going to be exactly the same slope as this green secant line. And so I guess if I follow this pattern or this slope, this slant, I'm going to say, and I'm sorry that I'm doing like a bunch of little lines here, but I'm trying to hit the point. I don't know, maybe somewhere there. At that particular point in purple, the tangent line has the same slope as the secant line. That's what the mean value theorem is telling us. It's relating one rate of change with another rate of change. And it's telling us, does a point exist in that interval, in that window between -2 and +7, such that there's a point, is there a point in there where the slope is the same, right? It'd be nice if that was always true. I look at the one right under it, h of x, and we're going to do the same thing. So I'm going to, as best as I can, draw my secant line. So it looks something like this. So the slope of this green line is the average rate of change, the slope of the secant line. But the question is there a point, and maybe that point is like right here, where the line just skims the curve at that one point, that it has the same slope as the green line, the slope of the secant line. And so this is the average rate of change in green. The slope of the purple line is the instantaneous rate of change. And there is a point between my endpoints being the marked points at x equals 0 and x equals 8. So in between, there is at least one point where the slope is the same, right? When I go over to k, however, I run into an issue. I'm going to draw my secant line. Here's one of my, again, if I had a ruler handy, I could just make a better line here. But this is my secant line connecting the two endpoints of my interval. So this is from x equals 2 to x equals 4. And the question is there a point somewhere in between x equals 2 and x equals +4 where the slope is the green line, is the same as the slope of the green line? But when I try to do these slopes, like all of these slopes are like over here, right? They don't have the same slant as that one. That one's really, really steep. So in this case, I can't find a point. So there is no point where the IROC, the instantaneous rate of change, equals the AROC. Over here, there was a point, and that point happened, or at least we guessed that it happened somewhere after 4. And in the first example, we said, oh, maybe the point happens at 5. But with k of x, there was no point. There is no point where if I draw the tangent line at that point, it's the same slope as the green line, the secant line. So why does it work with these two but not the others? And we still have one more function at g, so let's do the last function here. I'm going to connect the 2 points the indicated points or the endpoints of my interval from x equals 1 to x equals 10. I'm going to connect those points with a line. Hopefully it's a line. Again, if you have a straight edge, you can just use a straight edge on your paper and connect the dots. So here's the slope that I'm looking for. Is there a point somewhere on in between 1 and 10 that has the same slope? Well, it's certainly not here because all these slopes are negative. These slopes are positive, but they're too steep. Any of these points, the slope is negative. These are all positive, but they're way too steep. And then at these points, the slope doesn't even exist. So there is no point in this picture where the I rock, the instantaneous rate of change, equals the A rock. So what is happening in the two situations where we see no point, where we will have a matching slope? Something happening in the first two, f of x and h of x, that's not happening in g of x and k of x. So I'm going to pause the video here, or I'm going to stop the video here, and I'm going to ask you to think about what special thing or what's weird thing, I guess, is happening with k of x and g of x within the interval that we're looking, right? We're looking between 1 and 10, or we're looking between 2 and 4. Something interesting is happening that's maybe preventing us from finding a point where the slope of the tangent line equals the slope of the secant line. I'll let you think about it. I'm going to pause, or I'm going to stop the video, and in video 3, we'll discuss it.